Good morning all. In this video, let us study about Introduction to Mechanics. So we are going to cover in this video the definition of mechanics and what are the various branches of mechanics. First of all, let us go to definition of mechanics. Mechanics, it is nothing but a science which deals with behavior of bodies under the action of forces. For example, let us see this seesaw. When children are sitting on the seesaw, because of the weights of the children, the seesaw may move up and down, which we observed in our childhood. So, here, when these loads are acting, how the seesaw is behaving, this is nothing but called as mechanics of this seesaw. Mechanics can be broadly classified into rigid body mechanics, deformable body mechanics, and fluid mechanics. Rigid body mechanics deals with rigid bodies, and engineering mechanics, rigid body mechanics, applied mechanics, all are one and the same. And in this course, we are going to cover only engineering mechanics or rigid body mechanics. So let us concentrate on this first. This rigid body mechanics or engineering mechanics or applied mechanics can be classified into two parts, statics and dynamics. And again, dynamics can be classified into kinematics and kinetics. What all these mechanics? Let us see now in our further slides. First of all, let us go to rigid body mechanics. Rigid body mechanics, it deals with state of rest or motion of rigid bodies under the action of forces. So when forces are acting on on a rigid body, how it behaves, it is called as rigid body. But first of all, what is meant by rigid body? Let us see. Here, many times in mechanics, rigid bodies we consider them as particles. That is why for understanding what is rigid body, let us start with particle. As we all know, particle is nothing but a point mass. It has no dimensions. Okay, but whereas rigid body, it is a combination of so many point masses. It consists of so many point masses. That means so many particles. Rigid body is a combination of large number of particles. In a rigid body, the particles they remain at some fixed distances between them. But even after the application of forces also, if that fixed distance remains same, then then only we can call that body as rigid body. That means what we can understand under the application of forces, if the shape or size of the object does not change, then we can call the body as rigid body. Then if the shape or size, if it is not changing, then what happens to a rigid body under the application of forces? It may get translated or it may get rotated. For our understanding, from now onwards in the further slides, I am going to use this body as a rigid body. Here let us see what is translatory motion and what is rotational motion. When this force acting on this body, then as it is rigid body, there will not be any change in shape or size, but the object simply will get translated from one position to another position. This is translatory motion. Now, what is rotational motion? Under the application of forces, you see if the body gets rotated like this, but there is no change in shape or size. The rigid body mechanics can be applied to static objects and dynamic objects also. What are meant by static objects? Here in this example, you can see the bridge truss shown here or the roof shown here are the objects which are at rest even under the application of forces. You see, when vehicles move on this, the weight of the vehicles or the dynamic loading of the vibrations of the dynamic loading of the vehicles, that when it acts on the bridge truss, even then the bridge truss remains at rest. In the similar way, when the weight of the upper stories of the building, when it acts on this slab, still the slab is at rest. That is why we can we can call this science which is dealing with the behavior of these bodies which are at rest is called as statics. And now in dynamics, dynamics deals with the bodies which are in motion. Dynamics can be further subdivided into two parts, I said in earlier slide, kinematics and kinetics. Kinematics is nothing but the study of motion of the particles or bodies without any reference to mass of the body or the force acting on it. That means what we study here, only the properties of motion, that is like velocity, acceleration, displacement, the relation between these variables only we study in case of kinematics. And in case of kinetics, we study the relation between the properties of the motion as well as the force which is causing the motion. That is why it can be defined as the study of motion of particles and bodies with reference to mass of the body and forces acting on it also. So, how do we relate the properties of the motion with the force which is causing the motion? We can study in our next week's contents. Now, what is deformable body mechanics? Before going to see what is deformable body mechanics, first of all, let us understand deformable body. It is just opposite to rigid body. Here, under the application of forces, there is a possibility of change in dimensions. So, shape and size may alter after the application of forces. Now, the science which deals with the state of rest or motion of deformable bodies under the action of forces is called as deformable body mechanics. What is fluid mechanics? Why fluid mechanics is separated from deformable body mechanics? Even fluid also, it tends to change its shape under the application of forces. It tends to flow under the application of forces. That is the difference. For deformable body mechanics, only the change in size or shape may be possible, but fluid tends to flow. That is why fluid mechanics, it is separated from deformable body mechanics. So fluid mechanics can be defined as a science which deals with state of rest or motion of fluids under the action of forces. So the reference textbooks used for this video are given here. They are from Baer and Johnston, Vector Mechanics for Engineers by Baer and Johnston, Engineering Mechanics by R.C. Hibbeler, Engineering Mechanics by Rona Pratap. Thank you for watching the video. Let us meet in our next video, Introduction to Mechanics, Part 2.